What if you could think like a financial fraud analyst, but at machine speed? Not just detecting suspicious transactions, but questioning them, validating them, and understanding why they matter. Introducing Vanguard Sentinel, a multimodal intelligence system built for real-time fraud analysis and simulation. Isn't just automation, this is analyst-in-loop AI. Let me show you how this works in action, and then we will break down the architecture behind it. So, let's start. Hello guys, welcome to next video by Project Maker. In this video, I will be demonstrating my new project which is Vanguard Sentinel. As promised, without wasting the time, let's directly start the project demonstration, and after that I will explain the technical details after that. So I will simply open command prompt in this folder. And as you can see, the command prompt has opened in this folder, and I will simply first activate the virtual environment. So the command to activate virtual environment is venv/scripts/activate. As you can see, the virtual environment is activated. Now let's simply execute the application. So I will simply type python app.py. So as you can see, the application is ready and we can see the application at this address. So I will simply control click on this URL, and as you can see, this is the beautiful user interface of Vanguard Sentinel. Now let's directly jump into the signal intelligence to test this project. So as you can see, this is a signal intelligence page which shows that real-time financial anomaly classification. And as you can see, if we scroll down, below is the list of features that we should provide input, and based on the transaction input that we provide, the system will give us the output. So first is asking me to select assessment model, and I have provided 6 models option to choose, and they are XGBoost, balanced random forest, LightGBM, logistic regression, random forest, and XGBoost. All of these models are trained on the Banksym dataset, about which I will talk in the later part of this video. So let's simply select this random forest, and it's asking me to select any age, gender, category, merchant ID, and amount. So for now, let's add random details to test it. So I will select gender as male, category as transportation, so let's change it to home. Merchant ID, let's select this 729, and amount let's say 68, and for your information, this is in dollars. After that, I will simply click on this execute analysis, and this is showing that signal resolution is validated, which means this is not a fraud transaction, this is a valid transaction, and the risk is medium risk. But as you know, detection alone is not enough. You need to understand why this system flagged this transaction as validated. And the answer is in front of you, which is of neural reasoning. In this, Vanguard Sentinel breaks down the decision using Explainable AI, grouping complex model features like merchant ID, category, transaction, and intensity, and that helps system to give such reason. And as you can see, in this case, merchant ID played a significant role in identifying the transaction type. And the reason could be all the transactions where this merchant ID was included were mostly validated. Now let's take a look into the new scenario, which is what if analysis. And as you can see, this what if analysis simply tells the current input what will happen if the amount was double, or if we add a small amount to it. And as you can see, if we add a double amount, the risk category changed by 13.7%. So let's directly test it. So our current amount that we added is 68. Now let's make to 130, more than double, and simply click on execute analysis. And as you can see, this signal resolution is analyst, which means it is not fraud transaction, but the risk is medium. So using this what if scenario comparison, we can do analysis driven approach. So now let's try something else. I would like to let you know that I have provided a feature where I can directly inject the values from the dataset. And we can do this simply by clicking on the generate synthetic signal, which means simply add random values from the dataset. And as you can see, the values are changed. If we want, we can change the model also. The age is 26 to 35, gender is female, category is transportation, merchant ID, and the amount. And if I simply click on this execute analysis, it's simply showing it's validated. The risk is low because the transaction details are valid transaction. And as you can see, this time the category helped a lot to identify if the transaction was real or fraud. Now let's simply try with some other automated input. So I will simply will simulate data once again. And as you can see, the data is changed. And if I simply click on this button, then it's simply showing it's low risk and the engine is LightGBM. Certainty is 100%, which means the system is 100% sure that this is the validated transaction. And as you can see, this was just for the single transaction. Now for large-scale validation, Vanguard Sentinel supports batch analysis across historical data. So let's simply test that by clicking on this practical deal button. This is kind of simulation, where we can take random values from dataset and it will simply show the actual output and expected output. And as you can see, it's asking me to select a neural coil, which is the model. We can choose any of the model from the 6 options, and it's asking the signal batch size. So let's keep it to 10. And as you can see, almost all of the transactions are showing correct, which simply says the actual output is fraud and expected output is also fraud. So the answer is correct here, as you can see. So as you can see, for this batch, the model predicted all outputs correctly without any errors. So now let's try some another model. Let's say balanced random forest. Let's keep it to 9 and simply click on this initiate drill button. Let's check it once again. And as you can see, still the model has identified all the outputs correctly without any errors or mismatch between expected output and actual output. So now let's try once again by different model. And here comes the mismatching part. Model predicted it was fraud, but it was actually a legit transaction, which means a valid transaction. And the probability is of 76%, as you can see. So this proves that sometimes model fails because no model in the world is 100% accurate. So this was all about the simulation flow, where we can simply do batch processing to save our time. These were the main 2 sections, which was signal intelligence and tactical drill. In signal intelligence, we simply provide the manual input and tested the output and also did what if analysis. And in this tactical drill scenario, we simply picked batch records from the dataset and tested them. Now let's take a closer look at the command center behind Vanguard Sentinel. So for this, I will simply click on this HQ home page. Now let's understand what's present in this page. At the top, you will find the system's primary operational modules, which is signal intelligence and tactic drill, which navigates to the appropriate pages where we can do manual testing and batch analysis. Moving forward, here are the 3 intelligent core capabilities of the application. The first one is 3-tier engine. This engine assigns adaptive probability scores, instantly classifies transaction into low, medium or high that we just saw, enabling rapid decision making in critical environment. Next is the signal explainability. This is powered by SHAP, and for your information, SHAP is a framework which simply tells us the reason behind the model decision in human understandable way. And last but not least, the Sandbox scenario, a real-time simulation environment where analysts can test what-if scenarios that we just tested just by clicking the analyze scenarios. Moving ahead, this is the protocol workflow. Every transaction that we add in this application passes through these 3 stages, which are signal ingestion, neural analysis and final resolution. These 3 stages simply take data and do multimodal processing and finally provide the risk score and the explainable output. In this project, I have mainly focused on recall because the dataset that I have used is highly imbalanced with probability of 95:5, which means 95% were the valid transaction and only 5% of them were fraud transaction. This system is built for high financial environments. And I would like to let you know that this is not just monitoring, this is active financial intelligence. So this was about the home page. Now let's simply move to the dataset exploration, which is available in this intelligent dex page. At the core of the system lies the BankSim dataset, which is this. And the special thing of this dataset is that instead of using real-world data, BankSim generates highly realistic synthetic transaction. This ensures 2 things, data privacy and statistical authenticity. The dataset is built using combination of statistical modeling and social network analysis. And at this scale, this dataset simply has close to 6 lakh records, making it robust to simulate real-world financial simulation. Now let's move back to the user interface. Moving forward, these are the basic analysis that I did, which was fraud versus non-fraud transaction. And as you can see, the ratio is of 95 and 5%, which I told you previously. After that, I have simply analyzed the fraud count by gender. Apart from male, female, there were unknown categories also and enterprise level category also. And if you want to see the categories by fraud count, sports toys, health, beauty, travel, hotels, and so on. Moving further, here comes the most important part of this system. Here, as you can see, I have provided the feature definitions, which is age. In the dataset, the age is categorized by 0, 1, 2, 3 and so on instead of actual age. So I have simply categorized the age into the numbers that I just demonstrated you in the age dropdown, which was this. So as you can see, I added the numbers here and the category also, if you can see. So coming here again, the gender column in the dataset contains the short forms of actual names, which is M, F, E and unknown. So I have simply added full form of those, which is male, female, enterprise and unknown. The next feature is the amount, which simply means the amount used in that transaction in the relative currency. And the categories, which simply means the category of merchant, whether it was travel, leisure, home, entertainment, food, etc. So all of this feature makes the Vanguard Sentinel not just powerful but also safe for research, testing and simulation at scale. So this was all about the dataset. Now let's simply move to the model analysis. So as told previous, I use this 6 model: logistic regression, random forest, XGBoost, balanced random forest, XGBoost and LightGBM. And the benchmarking comparison of all these models is in front of you. This is the accuracy comparison, this is the F1 score comparison, this is precision comparison, and this is ROC AOC score comparison, and finally, which is the most important part, recall comparison. Now let's simply move to the individual model share comparison. This is for random forest, XGBoost, LightGBM, balanced random forest and XGBoost, and finally comes the logistic regression model. And here I have specifically mentioned that the primary matrix is recall because the dataset is highly imbalanced data. So this was all about the model analysis. You can take a close look on the results of each model simply by pausing this video. Now let's move to the next part, which is the blueprint. And this blueprint page simply includes the system architecture and ER diagram. Now let's start by exploring the system architecture. The platform follows modern 3-tier architecture designed for scalability, modularity and high performance interface. At the top we have a presentation layer created using HTML, CSS and JavaScript. This layer handles all user interactions from transaction input to visualizing the output, risk goals and explainability insight. Every action from user interface is asynchronously communicated to the Flask backend server using API call, ensuring a smooth and responsive experience. And moving next to the application layer, this is powered by Flask-based backend. It handles request routing, feature preprocessing, model selection, and coordinates interface across multiple machine learning models. So let's understand the flow. When the transaction is received, the backend performs raw inputs into model-ready vectors, which means it simply converts the raw inputs into model-ready vectors, which can be processed by the models that are present in the backend. Once the predictions are generated, the system applies the risk engine logic, assigning probability score and mapping them to the risk tiers. Finally, all these results are sent back to the frontend where they are entered in real time. And at the core, which is this part, lies the 6 serialized machine learning models, which includes random forest, balanced random forest, XGBoost, LightGBM, XGBoost and logistic regression. All of these models operate as an independent decision model, which allows flexible comparison and analyst-driven validation. Now, coming to the data structure, which is ER diagram. This system is centered around transaction-driven relationship. Each transaction record is defined by multiple attributes such as age, group, transaction, amount and category. Entities like customer, merchant and transactions are logically connected to reflect financial interactions. This is what that enables Vanguard Sentinel to operate as a real-time financial intelligence system. So this was all about the blueprint of the project. Now let's move to the last section, which is unit intel, which simply means the about section of this page. The main mission directives are detection accuracy, scalability and user accessibility, which collectively says that this platform isn't just a technical system, it is a targeted initiative designed to secure modern financial ecosystem. And moving ahead, I have just added the dummy picture of the creators that I have taken from internet. So this is all about my entire project, where I walk you from the basic project demonstration to understanding the technical details of this project. If you have not understood anything related to this project, then you can simply ask your doubt in comment section below or simply message me on Instagram. This was the technical architecture explanation of the project. Now let's simply jump into the folder structure. So as you can see, this is the folder structure and the first folder is of data. So this data contains the CSV file that I downloaded from the Kaggle website. And this is the Jupyter file, which includes all the steps to create a model by inputting this data. And if you want to see the models, these are the 6 models along with scalar file and the feature columns, which is the main backbone of the project. So let's move back. The next is the static data folder, where all the static files and images that I demonstrated are present. So this is the Flask folder structure that I followed. Coming to the templates, so these are all the HTML files that I just demonstrated, like about architecture, dataset, index, and so on. The next is utils.file. So here model handling and backend processing take place. After that, this is a virtual environment in which the application is currently running. This is the main application file or the starting point of this project. And this is the requirement.txt file, which includes a list of packages and versions that you may need to install on your end to execute this application. So this was the folder structure of this project. Now let's simply move to the user interface. So this was all about my project Vanguard Sentinel, which is a multimodal intelligence system built for fraud analysis and simulation. Let me know your thoughts about this project, and if you have anything to improve this project, let me know your thoughts in the comment section below, or also you can DM me on Instagram. I hope you enjoyed this video, and if you like this video, then don't forget to share this video with friends and family members. Here comes the end of this video. Thanks for watching this video.